So in Unit 2, we're going to talk about measurements and calculations with measurements and all the conversions and all that good stuff. To start off with, we have to start talking about exact numbers and approximate numbers. Is my computer screen up on your end? Okay, great. So an exact number is a counting number, is either a counting number or it's a defined number. By a counting number, you might be looking at how many studs it takes to build a wall. You would count them, and it's going to be that amount. If you need 15 studs, it's 15 studs. Or the number of students in the class. Those are counting numbers. I would just go around the room and count 1, 2, 3, 4, and so on. A defined number, we're going to use actually later on in this unit, would be like pi. That's used for your areas of circles and circumference of circles and stuff like that. There are other defined numbers like a natural constant and other constants. They may not be counting numbers, but they are defined. Approximate numbers is where we're going to spend most of our time and attention in Unit 2. Approximate numbers, for the most part, are measured. And there are a lot of different ways we can do measurements. I mean, there are meters and scales. If you're in electronics or automotive even, you'd be dealing with a lot of meters where you have to look at the scale on the meter and see where the dial goes. For this course, since you guys are dealing with construction, we're going to be dealing mostly with length measurement. We'll look at some of our other measurements as well. But for right now, let's take a look at length measurement and how it works. Length measurement, and actually any measurement, involves just comparing an object to another known object. And we'll get into the actual units of length that we use later on. For right now, but let's just say we're using an object, period. So let's say I have a block that is my unit of measurement. If I want to measure something with that block, I'm going to take the block, and I'm actually going to duplicate the block here quick so I can use it. And I'll start on one end of my object, setting it down there, and I'll just move it along. So there's 1 block, 2 blocks, 3 blocks, 4, 5, 6. So it's more than 6 blocks. It's between 6 and 7 blocks. Now you might be tempted, well, to say, let's just guess 6.5. Well, and it would be pretty close. But one of the things when we deal with measurement is we try not to guess in between our units because it's not very accurate. Now using that system, and that was how measurement started, was just taking that block and sliding along and counting. There's a lot of room for error. Now when I moved here, I had the shadow of the previous piece so I could line up that edge with where it ended before. But if you're sliding it along in real life, you don't have that shadow there. So every time you move it, there's an error introduced into that measurement. So at some point, they came up with the idea of, well, let's just take a stick and let's put our block up next to that stick and we'll mark off where the end of that block is, and we'll keep moving the block along and we'll keep marking off where the end of the block is. And that was the beginning of our first ruler. So let's say we have a ruler like this. Pretend these are evenly spaced. And let's take 2 objects here. We're going to take, using the ruler, we'd line up the object with the 0 end of the ruler. And we'd see where it ended on the ruler. Now I'm going to guess, since you guys have been working in the shop, you've used tape measures, so you've got some familiarity with measurement. What's that? Yeah, it's a skill that definitely is not guaranteed that people are good at these days. So anyway, I'm looking at this green object and this blue object, and I'm adjusting their lengths just a little bit here. So if I were measuring those with this ruler, both of them at this point are closer to the 2-unit mark, whatever units those are that I'm using. Well, like we said before, it's tempting to guess 2.5, but there is no half mark. And we resist that urge because our ruler, our measuring device, is only capable of going to the nearest unit. That's what we call the precision of that measuring device. Now, in order to make it more precise, we can divide the units up. I can put a mark here at the halfway point of each unit, and it's now more precise. Now, unfortunately, both my green and my blue object here are still now closer to the 2.5 mark. So this ruler, this measuring device, is still not precise enough to distinguish between those two objects. And that is, like I said, the definition of precision is the ability to distinguish between similar objects. So the precision of this ruler is not precise enough to distinguish between the green and the blue. So we'll keep going. Let's cut those in half. So if you ever wondered why we go in halves when we do measurements, instead of why do halves, quarters, eighths, and so on, instead of like tenths, which might be easier? Well, that's because when you have a unit, the easiest way to find a midpoint is just fold it in half. You find the middle. Back when they were developing measurement, they didn't have a lot of fancy technology. Cutting it into tenths would have been really difficult. Cutting something in half was simple. Well, if you cut it in half again, then you have fourths and eighths and so on. So looking here, putting in the quarter marks, now it appears, I would say the green one is closer to 2.25, and the blue one is closer to the 2.5. Oops, I wrote 2.5, I said 2.25. The green one's closer to the 2.25, and the blue one's closer to 2.5. Whatever those units are. So now at this point, this measuring device is precise enough, has a small enough degree of precision to distinguish between those two. So the definition of degree of precision is the smallest unit on the device. For most of us, that'll be a ruler or a tape measure. So here, the degree of precision of this ruler that we're using, this measuring device, is 1/4 of a unit, whatever unit it is that I'm using on there. Well, notice, let's take a look at that green object for a second, though. That green object is not exactly at 2.25. It's just the 2.25 is the closest marking to it. In fact, anything between here and all the way back to here would have been measured on this measuring device, on this ruler, as 2.25. It could be up to halfway to the next unit. So the distance from here to here is half of that degree of precision. Or, 1/4 divided by 2, or 1/4 times a half, is going to be 1/8 of a unit. And that is what we call the measurement error, or the greatest possible error in the measuring device. Because this measuring device only goes down to the nearest quarter unit, every measurement we make with this device has a plus or minus 1/8 of a unit possible error. So let's take a look at another example. Once again, pretend these are evenly spaced. That's good enough for now. So going up to the 2-inch mark, or the 2-unit mark, We'll say it's inches. We'll go ahead and give in and use the term inches. What is the degree of precision of this ruler? Well, we have to figure out what each one of those divisions stands for. So between 1 inch and 2 inch, how many divisions do we have? Now we're going to count the spaces, not the lines. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 spaces. That means each space is how big? Perfect. 1/16 of an inch. So the degree of precision of this measuring device is 1/16 of an inch. Its smallest unit, smallest division, is 1/16. So that means the possible error of this device is found by taking that degree of precision, that 1/16, and we can either divide by 2, or we can do 1/16 times 1/2. It works out the same. To me, when it's a fraction like this, it's easier to do times 1/2. 1/16 times 1/2 is 1 times 1 is 1, 16 times 2 is 32. So 1/32. So what that is saying is anything measured with this ruler has a potentially plus or minus 1/32 of an inch error. What that means is everything we measure here has a range that it could be. And that range is defined by that possible error. So let's say that we measure something with this ruler. And the object is measured to be 4 5/8 inches. The implied range of that measurement is 4 5/8 inches plus or minus our possible error in the measuring device. So 1/32 of an inch. So to find that implied range, we're going to start by taking 4 5/8 and subtracting 1/32 of an inch. To do that, we need to have a common denominator, which is going to be 30 seconds. 8's multiplied by 4 to make 32, so 5 times 4 is 20. So we subtract here 20 30-seconds minus 1 30-second is 19 30-seconds. So 4 and 19 30-seconds of an inch up to, if I added those together, I'm going to keep it as 4 and 20 30-seconds instead of 4 5/8. If I add a 32nd of an inch to it, that would be 4 and 21 30-seconds of an inch. So with this ruler, if I measure something and I report, if I tell you that what I measured was 4 5/8 inches long, what I'm really telling you is it's between 4 and 19 30-seconds and 4 and 21 30-seconds inches long. So I want you guys to do, in your notes quick, I want you to look at this ruler, and I want you to tell me, what is its degree of precision, and what is that possible error or implied error in that measurement? Find both of those real quick for me. So what's our degree of precision here? What's our smallest division? I go between 1 and 2 inches, how many spaces are there? One, two, three, 4, 5, 6, 7, 8, right? So 8 spaces in an inch implies that each space is how much of an inch? An eighth. Good. So our degree of precision is an 1/8 inch. How do we find our possible error from that? Well, it's half of that. So we can either divide by 2 or multiply by 1/2. 1/8 times 1/2 is 1 times 1 is 1. 8 times 2 is 16. Perfect. So that is a possible error of plus or minus a 1/16 of an inch. So that means that any measurement we report with this ruler. Yes, sir. You have a question? Did you add them or subtract them somehow, or maybe did you put the wrong key in? Maybe hit 3 instead of 1 on one of them. Oh, that's what it was. You did 1.5 instead of 0.5. Okay. I say you had me stumped there for a second. Okay, so what that's saying is anything on this ruler that we measure has an implied error of a 1/16 of an inch. It could be a 1/16 of an inch smaller or larger than what we're reporting in its measurement. Because anything between here and here is going to get reported as 7/8 of an inch. It's going to go to that marking right there. So let's say we measure something and we report it as 7 1/2 inches. There's an implied range there. That implied range, again, is we take our 7 1/2 and we subtract our possible error of a 1/16 of an inch. So to do that, we got to find a common denominator, which is going to be the 1/16. 1/2 is 8/16. 2 times 8 is 16. 1 times 8 makes 8. So we can subtract to get 8 minus 1 is 7. So 7 7/16 inches to, I'm going to leave 7 1/2 as 7 8/16 plus my error of 1/16. So 8 plus 1 is 9/16. So 7 9/16 inches. Any questions? Okay. So one of the things I want to look at here is I want to look at just kind of practicing this skill of getting that range and make it a little bit easier for you, a little quicker than having to do common denominators like this. So let's say we have a ruler that goes to the nearest 1/8 inch. That implies a plus or minus how much? Precision of 1/8. We'll do 1/8 times 1/2. 1 times 1 is 1. 8 times 2 is 16. So if our ruler measures to the nearest 1/8 inch, we have a plus or minus 1/16. Basically, you're taking the denominator of that degree of precision and you're doubling it. So if we have a ruler that measures to the nearest 32nd of an inch, that's implying plus or minus how much? One. If we double 32, what do we get? 64. So plus or minus 1/64 of an inch. If we have a ruler that measures to the nearest quarter inch, that's implying plus or minus what? 1/8. Very good. To the nearest 1/8. We've done this about 3 times so far, so hopefully we got this one. Plus or minus 1/8, or to the nearest 1/8 implies plus or minus 1/16. Great. So you can see to find that possible error, the plus or minus, we're just taking our degree of precision and we're multiplying the denominator by 2. The nearest quarter inch becomes plus or minus 1/8 inch. So now let's take a look at what if we have a ruler with a plus or minus 1/16 of an inch, and we have a measurement of 7 3/4 inches. To find the range, the first thing we have to do is change this 3/4 into 16ths. So what do we have to do to a 4 to change it into a 16? Well, 4 times what makes 16? 4. Perfect. So what do we do to the 3? Also, perfect. So 3 times 4 makes 12/16. So 7 3/4 is equal to 7 12/16. But now we're going to use that to find our range. Since our error is plus or minus 1/16, we're going to subtract 1 from this. What's 12 minus 1? 11. To adding 1 to that, what's 12 plus 1? 13. So the range implied here, if we have a ruler that measures to the nearest 1/8 inch, and we get a measurement of 7 3/4 inches, it's implying that that is between 7 11/16 and 7 13/16 inches. So let's say we measure to the nearest 1/16 of an inch. What's that implying for a plus and minus? 1 double the 16, what do you get? 1/32 of an inch. Good. So plus or minus 1/32. If we have a measurement that's reported as 5 3/8 inches, what denominator do we need to make this into? What our plus or minus is, what our error is. Our error is 30 seconds, so we need to turn this into 30 seconds. What do we have to do to an 8? What do we multiply 8 by to turn it into 32? 4. So we do the same to the 3. 3 times 4 makes 12. Good. So it's plus or minus 1/32. So minus 1/32 would be 5 and how many? 11. 12 minus 1 would be 11. Plus a 32nd would be 5 and how many? 13. Good. 30 seconds of an inch. So again, if we have a ruler or a tape measure that goes to the nearest 1/16 of an inch, if we measure an object at 5 3/8, what that's implying is it's between 5 and 11/32 and 5 and 13/32. And again, the reason for that is because if we look at this ruler, this is 5, this goes to the 16th, so 1/16, 1/8, 3/16, 1/4, 5/16, 3/8, and so on. We said this measures 5 3/8. So I keep going a little bit here. 5 3/8 is right here. Anything that measures 5 3/8 can actually be from here all the way over to here. So it has that implied range. And that's the limits we're setting here. This bottom limit is the 5 and 11/32. This top limit is the 5 and 13/32. So when we are dealing with standard units like this, where we're expressing our units, our measurements in fractions, we have to know something about the ruler in order to be able to define the range of that measurement. Now, if you get to the CNC side of things, machining, or in just woodworking, cabinetry, or the CNC cutting and the woodworking side of things, a lot of times we're going to measure in decimal inches to 100th or 1,000th of an inch. Now with wood, we very seldom measure anything to something more precise than 100th of an inch, because with wood you have temperature differences and humidity differences. It can expand by way more than 100th of an inch. Now if you get into metals, we'll go down to 1,000th or a 10,000th of an inch. But when we look at those decimal measurements, like 5.82 inches, the degree of precision here is implied by the measurement itself. The way I'm going to describe this is using this. If I have 5.1 inch or 5.10 inch, is there a difference between those two measurements? Well, numerically, there is no difference between 5.1 and 5.10, is there? They are exactly equal in value. But when we're talking about measurements, there is an implied difference. 5.1 inches, that is implying that I measured this on a measuring device. Here's 5 inches. Here's 6 inches. That 5.1 inches is implying I measured this on a device that goes to the nearest 1/10 of an inch. And what we measured happens to be somewhere in that range, closest to the 5.1 or 5 1/10. The 5.10 here implies that what I'm measuring it on pretend these are evenly spaced again. Yet one more day where I wish I was better at drawing. So anyway, you see here, for this one, it is actually divided down to the 100th of an inch. But the 5.10 is still telling us it is closest to the 5.1, or 10 hundredths. So it's giving me this narrow range here instead of this wider range here. So a lot of people do this kind of carelessly. They'll take a measurement like 5.1 inches and they'll just put a 0 on there, make it 5.10. Doing that is misleading to whoever's reading that measurement, because if they're using measurements properly, seeing this, like I said, implies our measuring device was much more precise. So if I give you that 5.1 inches, what it is implying is there is a degree of precision that is equal to the place value of the last digit. There are some exceptions about that last digit, and we'll go over those in a little bit. So the last digit here is the 1. What place value is that in? Well, that's in the tenths place, right? So this measurement here, 5.1 inches, is implying a degree of precision of 0.1 inches, a tenth of an inch. If I have something like 7.38 inches, that is implying a degree of precision of, what's the place, the last digit there is the 8. What place value is that in? Must be the tenths, hundredths place. There we go, very good. So 0.01. That measurement is implying that we had a measuring device or a ruler that was precise to the nearest hundredth of an inch. So let's go back up here and talk about possible error. What is the possible error in this measurement? Well, how did we find possible error from our degree of precision before? We took the degree of precision and we either multiplied by 1/2 or we divided by 2. So 0.1 inch is our degree of precision. If we divide that by 2, we get 0.05, right? So our possible error there is plus or minus 0.05 inches. For this one down here, 7.38, we had a degree of precision of 1/100th of an inch. Our possible error is going to be found by taking that 1/100th of an inch, 0.01, divided by 2, which is going to give us, there I heard somebody whisper it, 0.005 inches. So that is plus or minus 0.005 inches, or plus or minus 5/1000ths of an inch. So let's look at another measurement here. Let's take 9.4 inches, and I want to find now the implied range. Before, when we were dealing with fractional inches, we had to know something about the ruler to get the implied range. Well, we had to know something about the ruler to get the degree of precision and the possible error. Now we can get that all right out of the measurement. So we go through what we've done already. Degree of precision. What degree of precision is implied in this measurement here? Well, the last digit is the tenth of an inch, so 0.1 inches. So that implies a possible error. Take our 0.1 inch and divide by 2. 0.1 divided by 2 is 0.0. There we go, 0.05 inches. Only 1 0, 0.05. So that's a possible error of plus or minus 0.05. So the range that is implied here is going to be our original measurement, 9.4 inches, minus that possible error. Minus 0.05 is 9.35 inches. To our original measurement of 9.4 inches plus that possible error of 0.05. So 9.45 inches. So 9.4 inches, knowing that that's a measured number, is implying that whatever we measured is actually between 9.35 and 9.45 inches. Let's say I'm going to report something as 2.70 inches. And I will say that that 0 is correctly reported here. So let's look at our degree of precision. So the 0 is our last place value here. What place value is that in? What decimal place is that in? 0.01. Good. So it's in the hundredths place. 0.01 inches is our degree of precision. Our possible error, .01 divided by 2, 0.005. Very good. Plus or minus 0.005. Our range, well, 2.70 minus 0.005, 2.695 inches, to 2.70 plus 0.005, which is 2.705 inches. I'm going to have you guys try one of your notes. See if you can come up with the implied range for this measurement. So 8.32 inches. Try to give me the implied range for that measurement. So looking at this, what is our degree of precision? .01, there you go. Our possible error is plus or minus 0.005 inches. Good. What'd you come up with for a range? It'd be 8.32, not 5. 8.32, our measurement minus our error. So that'd be 8.315. So that's our lower end up to our measurement of 8.32 plus our error. So that'd be 8.325 inches. So when we report 8.32 inches as our measurement, what we're saying is it's somewhere between 8.315 and 8.325. Now, I had mentioned earlier that there is an exception to that degree of precision, being just the last digit. If I have a measurement like 420 inches, there's a gray area here. Is this measured using a device? Oops. Is this measured using a device that goes to the nearest inch? Or like this. So it measures to the nearest inch, and this was just closest to 420. Or was this measured on a device that only measures to the nearest 10 inches, and it happened to be closer to 420? There's quite a difference between those two. So in measurement and math, it kind of goes through all sorts of branches of mathematics, measurement, statistics, everything else. One of the rules we go by when we're doing error analysis is unless we can prove otherwise, we assume the worst. So looking at our 420 inches, since there is nothing there that tells us which of these two possibilities it is. Did we measure to the nearest inch and we're within a half inch of 420? Or did we measure on a device that goes to the nearest 10 inches and we're within 5 inches of 420? Since we can't distinguish between them, we assume the worst, which would be this second case, where we really were only able to measure to the nearest 10 inches, and we're closest to 420. So that means that we are going to assume a degree of precision that is equal to the place value of the last non-zero digit. So 2 here is the last non-zero digit. So that place value is 10. So we're assuming a degree of precision here that this is measured to the nearest 10 inches. Which implies a possible error in that measurement of plus or minus, what's half of 10? 5. Of plus or minus 5 inches. So now 420 ended in 0. So we said we couldn't use the 0 as a degree of precision unless we were told otherwise. But we had something like 5.70. We used this 0 as a degree of precision. Why were we able to use this 0 and not this one? Well, because this 0 is after the decimal point. And being after the decimal point, there's no reason to put that 0 on there unless it's part of our measurement. And in just a little bit, we're going to get into a discussion of something called significant digits, which is kind of a deep topic, and we're just going to kind of touch on it. It will appear on a quiz, but we'll do that quiz actually as a group because it's one of those, it's more important if you're going into the sciences. If you do go on to engineering, you'll have to be aware of significant digits. But part of this discussion of significant digits is when do zeros contribute to our degree of precision and when do they not, like this one. Now, it is very possible to have that measurement of 420 inches and actually have it really be this top case up here, where we really did measure to the nearest 1 inch, and it was just closest to 420, within a half inch of 420. So to be precise, when we report that measurement, what we should do is this. We put a little line, a little bar over the top of the 0. That tells whoever's reading this measurement that that really does have a degree of precision of 1 inch. So that the possible error is half of 1, or 0.5 inches. So plus or minus 0.5 inches, which makes a big difference. Let's take a look at this in a different light. Let's say we have 710 inches. Now I'm going to list it like this, 710 like that with no indicator, or 710 with a bar over the 0. So help me out here. This one here is implying what degree of precision? It's implying we measured to the nearest what? What's that place value there? 10. So that's implying we measured to the nearest 10 inches. So that's giving us a possible error of plus or minus how many inches? 5 inches. Which is implying a range. Remember, how do we find the range? We take our measurement, we subtract the error. What's 710 minus 5? 705, right? To our measurement plus the error. What's 710 plus 5? 715. Very good. So that's implying a range of that. 707, that whatever we measured is somewhere between 705 inches to 715 inches. Now over here, by putting that bar above the 0, that's implying now that this has a degree of precision to the nearest, what place value is that 0 in? That is the 1's place, right? So it's a degree of precision to the nearest 1 inch, which is implying a possible error of plus or minus, what's half of 1? Half of 1 is 1/2, right, or 0.5? So plus or minus 0.5 inches, which is implying a range. I'm going to write this one out for us. Of our measurement of 710 minus our error of 0.5 inches. 710 minus 0.5 is 709.5. To our measurement of 710 plus our error of 0.5 inches. 710 plus 0.5 is 710.5. Very good. So that is implying a range of 709.5 to 710.5 inches. As you can see, quite a bit smaller range than over here. Now in practice, we don't see it a whole lot, but it is a good habit to get into of indicating if there's zeros like that, indicating that that really is part of the measurement. Okay. I mentioned the term significant digits. Now, like I said, significant digits is more of a chemistry and physics and engineering application of numbers. So we're not going to get really deep into it, and we're not going to be really picky about it. We're going to talk about it for a couple of days because we will have to talk about this a little more next Wednesday. When we calculate with numbers, with measurements, we have to be careful about how we round and stuff like that because of those errors in the measurement as well. And we'll go through all that. And like I said, when we take a quiz on it, we're going to do it together because it's a pretty tricky concept, and I want us to kind of walk through it. But it is important if you get on to the next level where you're going to do some precision work or precision design. It's important so that we don't let the error in our measuring device dominate what we're trying to do. So that we make sure, basically, in reality, we work backwards with significant digits to make sure that if we need to have a final result that's within a certain error, plus or minus, we work backwards so that we're using a measuring device that is precise enough to make that happen. But anyway, significant digits tell us if a digit in the number gives us information about the measurement. So does that digit give us any information about what we were measuring? Now we've hinted at this a little bit, so we're formalizing some of the stuff we've talked about here over the last half hour. If I have a number like 2,807 inches, I know that's pretty big, but that's okay. Obviously, any of the digits that are not 0, the 2, the 8, and the 7, those are telling us something about the measurement. So significant digits, all non-zero digits are significant. So like I said, the 2, the 8, and the 7 are significant. So that's the easy part. Anything that's not a 0 is telling us something about the measurement, which implies that zeros don't always tell us. So zeros are part of the measurement when they meet one of a couple of criteria, one of 3 criteria. 1, they are between other significant digits. So in this example I have up here, this 0 on this side of it has an 8 that's significant. On this side there's a 7 that's significant. So that 0 is significant. It is between other significant digits. So this number has 4 significant digits. If I have 570, obviously the 5 and the 7 are significant. This 0 is not between other significant digits. So that does not fit that criteria. .083. These zeros, again, are not between other significant digits. The 8 and the 3 are significant because they're not zeros. But those zeros are not between other significant digits. They do not fit that criteria. .905. Again, the 9 and the 5 are significant because they're not zeros. This 0 here, is that significant or not? Yes, because it's between other significant digits. This 0 is not between other significant digits, so it does not fit that criteria. .0730. So again, our 7 and 3 are significant because they're not 0. But none of the zeros here are between other significant digits, so they don't fit that criteria. Thank you. Our next criteria that would make a 0 a significant part of our measurement would be if it is otherwise unnecessary. This is a tough one because it really messes with our knowledge of vocabulary. Significant to most people means important. If you're significant, you're important. You'd be missed if you were gone. Well, in measurement, significant means it's part of the measurement, not that it's important to the number. So we're talking about significance or importance to the measurement, not importance numerically to the structure of numbers. For example, this 0 here, I can't get rid of that 0. It is necessary. So I can't assume it's significant. I'm not saying it isn't significant, and it's definitely important. Because if I take that 0 away, this is now 57 instead of 570. It greatly changes the meaning of that number. So it is very important. It's just not, we cannot assume it's part of the measurement. because it is necessary, it's needed. And the criteria is otherwise unnecessary. So what am I talking about when I say otherwise unnecessary? Well, I'm talking about zeros like this one here, after the decimal point and after other digits. This 0 here, if I take that 0 out and get rid of it, does it change the meaning of the rest of the number? No, 0.073 has the exact same meaning as 0.0730. At least numerically it does. So the only reason for this 0 to be here, it is otherwise unnecessary to the number. The only reason for it to be here is if it is part of the measurement. So otherwise unnecessary is basically saying after the decimal and after other significant digits. So that 0 is significant because it's after the decimal point and it's after other significant digits. The third way that a 0 can be significant, we've already seen this, is if it's indicated. How do we indicate it? Well, the only place that it could even be done here, these zeros at the beginning of the number, that one, this one, these two, those zeros are never, ever significant. Zeros at the beginning of the number without any significant digits before them, never significant. This one here is what I'm talking about when I say indicated. It's at the end of the number. It's after other significant digits, but it is not after the decimal point. It is before the decimal point. So the only way that one would be significant is if we indicated it. And we talked about this before. That's putting that bar above it. That's saying that we did measure to the nearest 1 inch. So if we look at some measurements using this criteria, let's talk about what digits are significant, what digits are not. So in this number, 52.70 inches, is the 5 significant? Well, it's not a 0, right? So it's significant. Is the 2 significant? Say yes. Yes. How about the 7? Yes. Those are give me's because they're not zeros, so those are always significant. The question comes down to this 0 here. Is that significant? Yeah. Yes. It is after the decimal point, and it's after other significant digits. So this number has 4 significant digits. So this one, 0.03090 inches. Is this 0 significant? No. Zeros at the beginning are never significant. This one? No. How about the 3? Of course. 3s are always significant. This 0 here is why? Yeah, it's after the decimal point, after other numbers. Also, it's between the 3 and the 9. It's between other significant digits. So I mean, that one's definitely significant on a couple of different levels. So the 9 is significant. How about this 0? Yes, after the decimal point and after other significant digits. So that number has 4 significant digits as well. So here, 7,020 inches. The 7? Yes. This 0? Yeah, because it's between the 7 and the 2, and we know the 2 is. How about this 0? Careful. It's before the decimal point, so it's only significant if it's either between other digits or if it's indicated. And it's not between other digits, and it is not indicated. So that number only has 3 significant digits. So 680 inches. Is the 6 significant? Yep. The 8? Yep. The 0? No, it is not significant. So that only has 2 significant digits. Made a very subtle change here. 680.0. The 6 and the 8 are still significant. Is this 0 significant? Well, not on its own it's not, but is this 0 significant? It's after the decimal point, and are there other significant digits before it? Yeah, there's 6 and 8 there. So that 0 is significant. Because it's after the decimal point, and it's after other significant digits. So what does that tell us about this one? It is, because it's between significant digits. So that has 4 significant digits. How about 5,800 inches? 5? Yes. The 8, of course. How about my zeros? No. So this has 2 significant digits. What if I do that? Well, my 5 and 8, of course, are significant. What about this 0? Yeah, because the bar above it tells us it's significant. What about this 0? Nope, it's still before the decimal and not between any other significant digits. So this number has 3 significant digits. So what if I do this? So now again, the 5 and the 8 are obvious. This 0, it is going to be, we're not sure at this point, but this 0 is significant because it's indicated, which means this one must be because it's now between other significant digits. So this is a little bit different way of thinking. And like I said, it's the zeros that we have to deal with. It's the zeros we got to figure out. We'll talk about this more on Wednesday. On Wednesday, we'll talk about adding and subtracting with measured numbers and how we have to round. And we'll talk a little bit about tolerances and absolute and relative errors and stuff like that. And how we use these errors when we're combining numbers and calculating with numbers. For now, I'll give you guys some homework to get started on here for the last 22 minutes or so. We are in the big book. On page 224. It is exercise 7-4. We'll have you do 1 through 11, the odd. On page 225. Exercise 7-6. We'll have you do 1 through 15, the odds. And on page 226, it is exercise 7-7. I'll have you do 1 through 15, the odds again. That should keep you busy for the next 20 minutes or so. I'll give you the time to get started on that. Anybody have any questions? Okay, Mr. Berghammer, I sent out a big packet of stuff for this unit to you. Did you get that?
Yeah, I did.
Okay, is that something, I know some schools have limits on photocopies and stuff. Is that okay for you to copy that off, or is that something I should copy and drop it off down there sometime?
I'll take care of it. I just didn't get a chance to get to it today.
All right, well, it's going to be, we're not going to get to it next week. It'll be at least 2 weeks before we get to it. I just wanted to make sure there was plenty of time for it.
Yeah, no, thank you.
Okay, thanks.